I would like to call Mr. Rajesh Kumar Pathak, DG Bharat 6G Alliance, and all the panelists, Dr. Naveen Yanduru, Axiro Semiconductor, Mr. Akshay Aggarwal, MediaTek, and Mr. Udayan Mukherjee, Intel, on the dais.
Good afternoon. I think this is a very exciting session, I will say, that we have discussed so many aspects related to 6G, but semiconductor was not covered precisely, and you will see here that from Intel inside, that has been the logo when we grown. We have all the three semiconductor, MediaTek. So one you can say even the network side, UA side, and the new, which is I'm sure that they will all introduce themselves. So I would like to welcome Dr. Naveen, CEO Axiro Semiconductor. So he specializes in high performance RF and wave ICs. With nearly 30 years in semiconductor industry, he has held leadership role at Qualcomm, Samsung, Texas Instruments, others, and is an investor and 26 US inventor of 26 US patents with 25 plus IEEE publications. So welcome you, sir. Mr. Akshay Aggarwal, Senior Director, MediaTek, leading next generation modem, CPU, 5G, 6G innovations, and with 25 years in the semiconductor industry, he has held global R&D and marketing role at MediaTek, Lucent, Silicon Labs, ST Ericsson. He holds multiple patents, publications, degree from IIT Mumbai, Carnegie Mellon University, and an executive MBA from UT Austin. Welcome you also, sir. And third, we have, as I told, Intel Inside, Mr. Udayan Mukherjee, and Chief Architect. So you can just imagine that I think whatever I am just telling, that's not sufficient to describe him. So it's already displayed there. So we welcome this eminent panel with me, and though our thought process is to have fireside chat, but I think I requested them if they can give their 5 minutes presentation initially, and then subsequently we have some fireside chat. Before that, just for giving background, I'll be just giving again a 5 minutes presentation on semicon policy from Government of India. I'm sure that you might have heard, I mean just for our foreign guests, it's important that Government of India announced 10 billion semicon policy, and there is always difference between the policy and implementation, but in this case you realize that over a short span itself, we have marched to a implementation stage, and out of 10 billion, more than 9 billion has already been committed. It means we have the proposal to give the grants I am referring to whenever we say 10 billion for the ecosystem development in the country, and that's like support for semiconductor and display system, the 10 billion, 9.7 for support for electronics manufacturing and allied. But I am referring to this particular first vertical where it says that semiconductor fabs and display fabs, compounds, semiconductor and ATMPs, design linked incentive, that was also first it was done in telecommunication where I was pioneer of design linked for telecom product, but subsequently it was brought here, and modernization of semiconductor laboratories. These are the fiscal supports like 50% on project costs and additional support like infrastructure, demand aggregation and all those things, 2+2 beneficiaries. Same way in case of compound there are 15 plus. In case of design, there are 100 plus. So this is just to give a sense how government is working in India for the supporting not only the manufacturing of end product, but from design itself. So design, development, and subsequently setting up the manufacturing facilities, including assembly, testing, and packaging. More important is this slide, where I think you can just see that Tata, that is their Dholera, Gujarat, that was the US dollar 11 billion investment, and these are the capacity. You can just see that how many nodes they will be manufacturing, and what is the this Micron will be doing in Sanand, Gujarat, and same way Morigaon and Sanand again by different Readiness. So if I recall, then sir, this Axiro Semiconductor has something to do with the Readiness. CG Power. Okay, so CG Semi is the name. So we have one on the panelist itself. So I think, sir, we want to just hear more from you. And these are the others: 6M, Foxconn, Punjab, NCDIL. So this is just to give a snapshot that India is actually not only just unveiling the policies, but in actual it's implementing as well. And this is some snapshot. So this PPT will be available to you on our website. So with this, I think I just thought that I set up this one, and let me first invite Dr. Naveen for his presentation. So over to you, sir.
Thank you very much. I'd like to keep it short and crisp so that we will have as much time for interactions during this fire chat. But without much delay, I would like to start my presentation. First and foremost, I would like to kind of introduce Axiro Semiconductor. Axiro Semiconductor is one of the first Indian semiconductor company which is shipping ICs in millions of units. So we ship millions of units every month into a lot of tier 1 customers. I see some people from Ericsson here. So Ericsson radios use our chips, Nokia uses our chips. Most of the beamformers and user terminals for OneWeb Leo constellation are powered by our chips as well. We've been there for a while, but we divested out of Renesas to form this entity as an Indian company named Axiro Semiconductor. With that, I would like to jump right into the topic of today, which is what are we going to do with 6G? And before I talk about how and what advancements we need in the design and manufacturing sectors, the first thing I would like to kind of set the stage is why do we need 6G? And here are some of the use cases that we are contemplating that could be supported by 6G, be it AI derived or otherwise, and also the brute data demand from everybody getting connected is also very important. Coverage related, like I said, AI related capabilities, and again, massive machine to machine and lot of AR, VR positioning as well as sensing applications are going to fuel the need for data rate and more speed from 6G. And that would be the compelling use case for 6G when we get there. Now, how are you going to fuel this big need for data rate and capacity? And this is my final slide, or maybe this is my penultimate slide rather. And we all know this very basic formula that we all learned as electronics engineers, and it gets as simple as that. If we need more capacity, Shannon has already given the maximum upper limit for a channel capacity with a very simple formula. Now, to get to this channel capacity that is given by this formula, a lot of modulation techniques have to be adopted so that you can get to this maximum channel capacity given a certain bandwidth and signal to noise ratio. But that is for the modulation engineers and the digital DSP engineers. And I'm not going to act like I'm one because I'm not one. But what we could do elsewhere in the RF analog antenna domain is to work on how can we increase the spectral efficiency so that we can increase the bandwidth, the B that you see here in the equation, and how can we design circuits that improve the signal to noise ratio. I think that will be the key advancement and the challenge that engineers will have to look is how are we going to harvest more bandwidth, especially going into FR2 frequencies and higher frequencies where there is a lot of bandwidth that is available. And also using spectral efficiency techniques, whether it's higher modulation techniques or other techniques where like beamforming, where you are using beamforming techniques to try and get your data and your signal to point in only the direction that you need to point at. And these are some of the ideas that you can use to try and prepare for 6G advancements. How do we increase bandwidth? Like I said again, try to farm the high frequency bandwidth that is available at higher frequencies, try to improve the spectral efficiency. And when it comes to signal to noise ratio, this is where the innovative minds have to be put together and how we are going to design circuits that are very low in noise and how are we going to make high linearity circuits so that we can get higher dynamic range to increase the signal to noise ratio. At Axiro Semiconductors, we have a strong legacy of doing that, and that is our claim to fame, or that is our USP. Over the last 15 years or so, we have been bringing compelling advancements and innovations to the wireless industry. Just a few of these I am showing here that increase the SNR of our systems as well as increase the bandwidth. A lot of our technologies that you can see, for example, flat noise technology is a very compelling technology that is used in wireless base stations, for example. Even as you back off the gain of our amplifiers, the noise remains very low. For example, the zero distortion technology that you see here is also a marquee innovation of our company, where we are able to increase the linearity and the signal dynamic range, where there is no harmonic content or intermodulation content. Thus you are improving the SNR to increase the channel capacity, like I explained in the previous slide. And when you come to this beamformers that you see in 2022 that we have introduced that are getting a lot of traction, both in SATCOM as well as wireless infrastructure, fixed wireless access, that is where we are able to form and take advantage of the higher frequencies so that we have more bandwidth that we can use to increase the capacity and fuel the capacity needs that are needed for 6G. Our DAP technology, which stands for dynamic array power, is a very good technology where we are able to keep efficiencies very high even when you back off the power from the maximum output power in class AB amplifiers. And that way we are not only contributing by using by accessing the higher frequency, but are also making green technology available, where we are making high efficiency amplifiers and beamformers for FR2 or millimeter wave frequencies. With that, I would like to kind of let my next speaker take over so that we will have ample time for discussions later. Thank you very much.
Thank you. Next, I think I invite Mr. Akshay Aggarwal.
Hi, good afternoon, everyone. And thank you, Naveen, for a very inspiring talk. RF front-end is something like a black magic, which always excites me. There's a lot of innovation to be done in RF, so definitely thank you for that, and a lot to see in RF stuff. So with that, once again, good afternoon. So I'm representing MediaTek. I'm a Senior Director of Engineering in MediaTek Bangalore. And for those of you who may not be familiar with MediaTek, it's one of the largest fabless IC design houses in the world, and our bread and butter is mobile communication, wireless communication, whether it's powering the mobile phones, the connectivity solutions, home connectivity, etc. So that's what we do. So chip is our bread and butter. We do chip design, and then we outsource it to fab houses for manufacturing and fabrication. So with that, I'd like to move on to the next slide. And so I won't spend too much time on this. I think all of you have seen this, and Naveen was also kind enough to show this, what's going on in 6G. So mobile communication, 3G, 4G, 5G is something which we are very passionate about, because that's what we do. So having made a mark in 4G and 5G, now we're looking at the next frontier of growth, which is 6G. There are lots of interesting stuff happening in 6G, or which is supposed to happen in 6G. Some of them being intelligent compute, pervasive coverage, and sustainability. So I'll talk about a few of these use cases and then also talk about how semiconductors can help in those use cases. So first of all, the mission of 6G is to have superior user experience from day one in immersive and sticky applications, which is going to give you pervasive coverage. Coverage is very important. Energy consumption is very important from base station perspective and from mobile perspective. And of course, cost is extremely important for democratizing technology. So you have to give the best ROI, which means the best features at lowest possible cost. Simplicity, which means the solution has to be simple enough. It has to be optimized for practical user experience, and it has to be convergent. Convergent means it has to give you best efficiency and performance. With these things in mind, we would like to go ahead and influence the 6G standards. Currently, as some of you who are involved in 3GPP, release 20 is going on, which is the pre-6G, and that's what we are trying to influence in the standards committee. So I'm going to talk about 2 or 3 slides as to what are our key themes of 6G and how we think 6G could be different. First of all, it has to be intelligent 6G, which is hyper-local integration of communication and compute. You know, it's no longer the case where you are actually transmitting to the base station and the base station is doing all the jobs. It has to be a personal area network where the devices are communicating with each other, they're collaborating with each other in all the functions that they're doing, and these functions could help you in better compute at a lower power. So something that was happening in 5G was mobile edge compute, or MEC. Now we would like to bring it closer to the devices, which means the devices will also interact with each other along with the edge network to have an optimal distribution of resources on how to allocate these tasks. And how the semiconductors come into picture over here is that the mobile phones or the baseband processor will have an intelligent AI chip which is going to determine as to what function should be done on the device and what function should be outsourced or offloaded to the edge for better efficiency and lower power consumption. So this is what we call as hyper-local integration of communication and compute. Along with that, the other feature that we're talking about is, which is, you know, kind of a sister feature, is ambient compute, in which, as you see over here, there's a personal IoT cloud. You know, smart glasses are becoming more pervasive, smart watches, IoT devices, mobile phones, but all of them are working in isolation with the network. How about if all these devices work with each other to do a compute offload? And again, for that to happen, you know, you need good AI processors which are going to determine what agentic AIs are supposed to run on the device and which of them are supposed to run on the edge cloud. But by doing this, you can have a good efficiency, power, and latency combination. And this has to be not an afterthought, but something feature from day one in 6G. Another very important thing which MediaTek is working towards is NTN NTN. You know, so TN networks are very popular right now, but NTN is something which is catching up. How to integrate NTN and TN is extremely important. So we've done multiple demos of NTN in in NTN IoT or NRNTN in MWC, where we have shown that devices which are powered by MediaTek, and similarly by other IC vendors also, they work closely with other LEO satellites and GEO satellites to give you very good connectivity. The challenge over here is how to integrate the spectrum, and for that also some device collaboration has to be required, and some chipsets have to be required on the NTN side, which MediaTek is working towards. And lastly, but not the least, is energy efficiency. There are going to be many, many more features that are going to be packed in 6G. So it is extremely important that the systems and the chips have to be more energy efficient. There are discussions of new waveforms that could come into 6G, and how do you optimize the PAPR, for which we'll work with, you know, our partners, RF vendors, to make sure that the baseband and the RF can work together, that energy efficiency is something which is maximized. Along with that, we are also working towards one last thing is FWA devices. which is fixed wireless access. In India, CPs or fixed wireless access is catching up. And in 6G, what we are trying to do is, we are trying to make 6G or FWA as a day one concept in FWA. So we are working with organizations like ATIS, and other organizations to see how we can optimize the chipsets so that FWA performance can be optimized. So I won't talk much more than that over here. We'll leave that to the fireside chat. But lots of interesting stuff happening in 6G, or which are supposed to happen in 6G, and we look forward to be powering it from the semiconductors point of view, and also from the systems point of view to make it a success.
Thank you. I think for considering, your plan are aligned to day one.
Yes.
Day one of 6G.
Yes.
Yeah. So I think with this, we'll have certain discussion during fireside chat. So I invite Mr. Udayan Mukherjee, sir, Chief Architect from Intel. We want to hear from you. What is your plan for day one?
Good afternoon. At the beginning, Pathakji introduced Intel as Intel Insight that we grew up with. I can tell you that if you look into 4G, 5G, Intel is the most dominant silicon suppliers for all the infrastructure part of it. So the base stations of the world and packet core of the world and other elements of it, whether it's a traditional RAN, ASICs RAN, or the open RAN or the virtual RAN, we provide the silicon to all of our telecom vendors. So in that context, Pathakji, it is indeed Intel Insight. But let me move on. I'll take a more infrastructure and system point of view, and that we will think about where is this going. If you look into 6G, one of the, and I work with all the Indian operators as well as globally with Verizon's, AT&Ts of the world, Vodafone. One question is hey, is it only data? Is it only the data? Is it the dumb data pipe that you are going to give me the same amount of money that we're going to give in 5G or 4G, or is it anything better than that? So there are a lot more. We have some promises in 5G. We never able to fulfill many of those. But in 6G, we are doubling down on those. And these are some of the system level use cases that 6G is really looking into. And ISAC, the integrated sensing and communication, is one critical aspect of it. If you look at the latest 3GPP spec, by the way, I also own the 3GPP team in worldwide for Intel. There are 32 use cases only on ISAC. So a lot more use cases are coming, and I'm hoping that this time there'll be much more opportunity for monetization than only a fat data pipe. Okay. And why am I saying this thing? Because this all has implication on the silicon architecture, and I'll show you a glimpse of a silicon architecture that we're working with. What are those aspects of this technology superpowers that you look at, which has reflection on semiconductors? It is compute. So compute and communication, if you want to do more than just a dumb pipe, then you have embed compute in every aspects of it, including the transport part of it, where we are looking into segmented routing again and see what we can do. And obviously, the sustainability part of it, the AI aspects of it, and all of those aspects has an impact. So you hear a lot about the AI, AI native and all of it. There are aspects of AI in layer 1, 3GPP areas like beam management and CQI, and I'm not talking about that, okay? I'm taking it one level up, and these aspects of system level AI, from the automation all the way to security, will be really put to task in our next generation communication. It's already happening now in the 5G advanced. And most of my discussion AI is not just on channel estimation or MIMO, but also on how do I actually automate by day 0, day 1, day 2 deployment, and how do I do a better root cause analysis through an LLM. So a lot of those discussion happening. So what does this mean, coming back to semiconductor? Just take I'm taking infrastructure part of it. Look into the packet code trend. Okay, that's a major part of the elements that operators implement. Back in 2020, half of this, 50% of this core network was not even virtualized. Today, 90% of the core network is completely virtualized. They have adopted the cloud infrastructure already. So it's all on the general purpose processing platform with core scaling, and a lot of the use cases coming from the best known practice of hyperscalers are getting into the packet core. But what about RAN, the major part of any network, whether it's going to be 5G or 6G, 90% of these things are not virtualized today. So the trend is again going to repeat. And this is the reason why. If you look into semiconductor cost of building something from a 65 nanometer to a 5 nanometer, there's an 18x increase in cost, whether it's a mask cost, or it's a design cost. So for every piece of it, you can't just keep building ASIC or tradition. We do that also for customers, but we know where the cost is going. It's exponentially increasing. What is that net translate to? Translate to that the RAN must transition to a power efficient silicon. And that is already happening. And that's a merchant silicon that you take economics advantage from other areas, like what you are doing in compute, data center, AI, and many other places. With that, I will show you two slides, and these are two specific to the architecture that we are working with, that my team works on. One is on the packaging side of it. One way to create more efficient, power efficient silicon as a system is integrating more and more functions that takes many different number of cores into a small accelerator and getting it. So this is a true SoC. So what we have done, something that in early days of Open RAN in 2018-19 used to be an accelerator card, a layer 1 card or a decoder or encoder card. We have taken that and put it in the SoC. So think of general purpose processing cores along with that targeted accelerators to make this thing more power efficient system-wide. That's the advanced packaging example. And then the other things that we are doing is our multi-core architecture. And this is just released already, but we're going to evolve it. Every core that we do, whether it's the 32 cores, 64 cores, 72 cores, every core will have an AI capability built into it. A real-time inferencing going to be built into it. So that tomorrow, if you have to do something, a better MIMO or channel estimation, beam management, you don't have to put an expensive piece of separate silicon into this, because this is still implemented at the edge, at the far edge. So that's how this is evolving. So there is a matrix multiplier, tile matrix multiplier in every core that helps in any kind of AI aspects of it. There's going to be targeted acceleration for LDPC decoders and others, so that you make the solution power efficient and scalable. So that's the last slide. I mean, what is the net? Whatever the use case that you're looking to, semiconductors are the foundation. I mean, you have to build on these things, and especially on the infrastructure side where we are playing a major role. And all the use cases and network transformations are actually impacting what the silicon design is going to be. And in addition to that, we are part of the standards committee. I mean, nothing has to be done proprietary. So whether it's in 3GPP or Udayan or in the TIP, we are making sure that this evolves and it doesn't get fragmented, the standards, so that I don't have to create multiple different ASIC or SoC variant for addressing this. Thank you.
Thank you. I think you heard that what are the various specific actions being taken by, one can say, network, RF, UE part. Now let us do, because this session is a fireside chat, so I thought that let's first listen them and then we can have some questions. We have some about 10 minutes. So sir, I think first part is that how the silicon architecture is evolving to address 6G. So I think I'll just ask from you, and others can also join, otherwise you can have other questions as well. So from you, what is your thought process?
So as I was talking about, especially taking the infrastructure side of it now, obviously power efficient silicon is the name of the game. And then it cannot be a targeted ASIC for all these aspects of the infrastructure. And then when you talk about AI native, if your layer 1 aspects has got all the AI capabilities that needs to be embedded in the platform. I just don't want to bring in every time a GPU at the far edge implementation. Even though we talk about cloud RAN for last so many years, every implementation of the RAN is still at the far edge. If you look into what's happening in Verizon, in AT&T, what's happening here. So you have to have a power efficient silicon which is scalable. Lot of also demands, and I was talking to our operators, they're asking for they're doing 4G spectrum farming, so they have to support 4G as well as 5G. In Europe, some of the cases, they still tell me, hey, you still have support for GSM, right? I said, man, how long I have to keep doing this, But we still have to, at least the 4G and 5G has to be there along with the newer changes. But 6G, the only thing that we know of that certain changes may happen is on some of the decoder side of it. LDPC is one example. There's some changes, and we need to make sure our accelerator supports that, and we are tracking there.
Thank you. The same, can you answer from your point of view?
No, I actually want to second on some of the thoughts that Udayan ji mentioned. And I think the merchant silicon idea of having multiple cores and having a tile structure to kind of take advantage of multiple markets given the cost of doing these chips is getting tougher and tougher. And even in the RF space, even as the investment is not as high, we still feel that is important. That way we can really take advantage of multiple markets running hot and cold to kind of spread our R&D investments across. And that would be a very important architectural choice that all the silicon vendors will have to make as they're making their investments into 6G. I would completely agree with that philosophy.
Thank you. And can you also just supplement, or should I?
Yeah, so I think when we are doing the chips, for any generation, there are 3 metrics that we look at or we are measured on. It's called PPA, power, performance, and area. So that's the most important metric for a semiconductor vendor. So from power perspective, I think both my colleagues already mentioned that power is very important, especially because, as we are putting more and more functionality into these chipsets, the power consumption becomes very important. From performance perspective, I think the couple of things that I would like to highlight. One is the baseband processes that we are doing are supposed to be or expected to be more intelligent, which means they know how to offload tasks, as I was talking about, in hyperlocal environment. Again, from the RF perspective and from a data rate perspective, more and more MIMO functionality has to be included with things like beamforming. That's extremely important. And from the area perspective, as the foundries are going towards 2 nanometers, 1 nanometers, I think it's going to be a very interesting play of area and power, because leakage power can go up. So that's something we have to manage. So these 3 metrics is something we have to look forward to as we go for 6G.
Thank you. I think as India, its 6G vision says, the 6G, we feel that has to be first affordable, but I think this one word has a lot of things. Affordable, sustainable, ubiquitous.
Yeah.
But how to make it affordable? I think you shared that device collaborations. That was, I think, I heard one thing. So if you ask, then what is that one component in the 6G? So people all say cheap, because that's something 60%, 80%. So my question will be, because people are thinking monetization aspects, someone say that it has to be driven by new use cases, and FWA also was touched upon that how can we, but I'm referring to all in the keeping in mind that how to bring down the cost to end user or maybe our rural India. So the next question will be that what are some of the monetization avenues or thought process for 6G? How you each think differently on the same this one. So you can start again from Saryu. And then,
yeah, so the operators have been trying to break open the stuff. One of the, and I'll give you an example, almost 5 years back, one of the US operator told me that, hey, I have more information on my subscribers, but Google makes more money. how can I change that? Well, it's not that easy to change. So every time we're trying to figure out a compute aspects of it, what functions, and a lawful intercept, or anything that can be monetization elements it can do. But in 5G, if you look into it, the mobile compute, and mobile compute you talked about, is after the packet code. What we are trying to do in system, there's a NextG white paper also, I think Amitabh is here. He actually championed some of those. We wanted to embed compute at every aspects of it. Whether it's in the radio, data, and the far edge, and base station, whether it's in a transport, segment routing is one example I talked about. So once you do this thing, that some of these applications come into play. For example, this ISAC I talked about, integrated sensing and comms. There are 32 use cases that talked about. Some of them are very critical. That unmanned vehicle, location, drones, getting into critical infrastructure. You already have mobile networks on this thing. Why not you turn that radios to a form of sensors? You don't need separate sensor for those. So, but there are challenges. Latest 3GPP reports I saw, the accuracy is still not where we want it to be. So there are challenges and opportunities. So I think there are serious effort this time to figure out where some of the monetization aspects can come from.
Again, very good thoughts those. I think ISAC clearly, and how we can take advantage of the RAN infrastructure already to bring up more use cases, because the money has to come, and if we have to make this affordable, somebody's got to pay, and the use cases have to start flowing, right? So ISAC clearly, I would agree, is a very compelling use case. And I know Pathak ji also mentioned, connecting the unconnected and getting full advantage of the NTN would be another thing that we should be looking for on how we are going to make 6G affordable. And on those lines, I think we haven't really seen all the implications of AI yet. I think we are still in the initial chapter of AI, and when AI gets fully unleashed, I think a lot of compelling use cases will come out, which will fuel the demand for more data. And I think that's where a lot of use cases, a plethora of use cases will develop, and that is when the operators will finally dig deep into their pockets and start asking for more and more radios and infrastructure that will fuel 6G.
To make it lower cost, you have to have economies of scale, which means you have to expand your market. You have to definitely go beyond the mobile market and go to different use cases, whether it's ISAC, whether it's NTN, whether it's AI, fixed wireless access. And that's where I think India can have a major role, because India is a huge enough market, a big enough market. So I think if India can play a bigger role in the standards committees like 3GPP and talk about some of these use cases and drive it towards there, whether it's with the help of Bharat 6G and other SDOs, I think that can be a huge impact. Because in the past, what has happened is people have talked about the use cases, but there has been no consolidated push in 3GPP from bigger markets to make that happen. So in my opinion, that's where an opportunity lies for India to play a role.
Yeah, thank you. I think one last, and you can reply. Again, what is your one killer application according to you for monetization in day one for 6G? What is your thought process?
I don't know there's a day one. I mean, all these things like fixed wireless and other elements of it, we've been talked around in 5G time frame. But this sensing and comm, I mean, is very exciting at this point. Use case, there are 32 use cases. I was telling the 3GPP, you should read that white paper that 3GPP published. That gives you a lot of thoughts. So that's what some of things that we are very excited about.
Thank you. Over to you.
Even if nothing, no use case pans out, just the sheer need for data that we need over time will mean that we will need the next G. So one way or the other, 6G is coming.
I think from our perspective, ambient computing, where the devices form a mesh and offload each other, and it's a good synchronization between the UEs and the network, is a great use case for 6G, and that's something new.
Thank you, my panelists, for at the last replying the same question in a collaborative way, and that's what I think we'll be just discussing in our next panel, which is all about the collaborations, cooperation, how can we work with each other because Bharat 6G Alliance has now MOU with most of the research alliances across the globe. It started with the NextG, then 6G IA, 6G Forum, and then XGMF, and even 6G Brazil, and then research alliances like UK India Future Innovation Network, UK TIN, and Federated Telecom Hub. We have Professor Herald here. That is some consortium of 27 UK institutions, and NGMN Alliance, like they represent how can you bring operators and provider and 5G ACI IoT components. So thank you all, and I think our next session will be immediately after this, since I'm utilizing this opportunity to invite my Vice Chairman and CTO, Tejas Networks, Dr. Kumar Sivarajan, to take it forward. So sir will just wind up in this one, and then you can just, because I think this will be the last session, and then we'll have the valedictory. Thank you.
Thank you.
On behalf of Bharat 6G Alliance, a sincere thanks to all the panelists for such an enriching session. Now I request moderator to present mementos to all the panelists, inviting Dr. Naveen Yanduru firstly. Now Mr. Akshay Aggarwal from MediaTek. Now Mr. Udayan Mukherjee from Intel. Now I request Professor David, Chairman of Bharat 6G Alliance, to present memento to the moderator. Sir, group photo. Oh, group photo. Yes, yes.